So you're probably keeping up with the breakneck speed of AI right now, right? I mean, every week there's a smarter algorithm or a faster response time.
Yeah, it really feels like the software just never stops evolving.
Exactly. But I want to completely flip the script today. What if the absolute biggest threat to AI isn't a lack of computing power or, coding genius, but literally just finding a place to plug it in?
Right, which is wild to think about. It's like the
Mhm.
ultimate reality check for the whole tech industry. We've spent decades assuming digital growth is just boundless, but we're violently hitting a physical wall now.
Yeah, and that is exactly the focus of our deep dive today. We're looking at this really fascinating civilization analysis thesis that focuses on the intersection of AI and energy, specifically these looming power constraints.
It's a great source because it forces us to look past the software and really examine the physical grid, which we almost never do.
Right. So, our mission today is to explore this profound structural shift. We're going to look at why AI's biggest bottleneck is now physical electricity, how it's triggering this massive global geographic reshuffle, and what all of this actually means for the future of intelligence as a resource.
Yeah, if you want to understand the future of tech, you really have to start looking at heavy infrastructure. It's a total paradigm shift.
Okay, so let's unpack this because I'm sure for you listening, it's just like it is for me. When we think of AI, we picture the cloud.
Which sounds completely weightless.
Yeah, weightless and infinite. But these sources paint a picture of a cloud that is actually incredibly heavy, grounded in steel, and just incredibly thirsty for power.
Yeah, and to understand why this current crisis is happening, we have to look at this massive collision of two very different speeds of growth.
Right, the exponential versus linear thing.
Exactly. You have AI power demand surging exponentially. And there are really three things driving that. First, you've got these massive GPU clusters,
It's
right?
just tens of thousands of specialized chips wired together.
Yeah, running simultaneously. Second, the hyperscalers, so, Amazon, Google, Microsoft, they're pouring billions into accelerating these investments. But the third thing, and this is the real kicker, is the shift toward always-on AI inference.
Okay, let's pause on that word inference, because I think
Right.
that's where the disconnect happens for a lot of people.
Or
Historically, we've heard a lot about AI training, right? Like feeding the model millions of books so it learns, which obviously takes a ton of power, but it's an event. It finishes.
right, exactly.
But inference is what happens after that, right?
Yeah, that's the critical distinction. Training is basically building the brain.
Hmm.
Inference is actually using it.
Oh, okay.
So when you ask an AI a question or have it draft an email, the model is inferring the correct output. And as AI gets integrated into literally every search engine and smartphone, inference becomes this continuous, relentless draw on the power grid.
It just never sleeps.
Exactly. It never sleeps.
Let's break down the mechanism there a bit.
No.
Why does generating a response require so much more baseline energy than, say, a regular internet search? Like if I search for a recipe, my phone talks to a server, the server finds it and sends it back.
Right. It's retrieving a file.
Yeah. Yeah.
So a traditional search is kind of like going to a library and fetching a book that already exists on the shelf. The energy required to just go grab it is pretty minimal.
Because the heavy lifting was done when the book was written.
Exactly.
Hmm.
But AI inference doesn't fetch pre-written books. Every single time you ask it a question, it's dynamically calculating the probability of the next word among billions, sometimes trillions, of parameters.
Wow.
It is writing a brand new book from scratch, on the spot,
Yeah.
every single time you hit enter.
Oh, wow. Okay, so doing that billions of times a day across the globe, I mean, that is an astronomical leap in power demand. It's just shooting straight up.
Yeah, the demand is exponential. But on the supply side, we have our electrical grid, which, as the source points out, can only grow linearly.
Right. It's like trying to fill this constantly expanding mega pool, which is our exponential AI demand, using a standard neighborhood garden hose.
That's a great way to put it.
The hose is our linear grid capacity, and it just physically cannot upgrade itself overnight to match the pool size.
Yeah, and in many places, it's not even linear, it's stagnant. You can't just copy and paste a power plant the way you copy code. You have to secure land, get permits, build physical transmission lines. It takes years.
So it's literally a fundamental mismatch in the physics of how fast we can scale software versus how fast we can pour concrete and lay copper wire.
Exactly. Which is why the Force argues we actually need to completely change our definition of what AI is. It's no longer just software.
Right. The core thesis here is that AI should be viewed as an energy transformation system.
Yes, converting raw electricity into intelligence.
I got to play devil's advocate for a second, though.
Go for it.
Calling it an energy transformation system sounds, I don't know, a bit dramatic. Should we really stop thinking of AI as a digital brain and view it more like a heavy industrial factory? I mean, it takes in raw electricity on one end and manufactures thought on the other.
What's fascinating here is that viewing it as a physical manufacturing process completely changes the economic and geopolitical reality of it.
How so?
Well, software is practically free to scale, right?
Mm,
Once the code is written, you distribute it to a billion people for basically zero marginal cost.
right.
But heavy industry, like aluminum smelting, doesn't scale for free. Every unit of output requires massive continuous physical inputs.
Oh, he.
So if you want more AI-generated intelligence, you need more raw power. In this structural breakdown, data centers aren't really IT buildings anymore.
They're what the source calls power concentration devices.
Exactly. And the grid itself is the ultimate supply constraint.
Okay, here's where it gets really interesting. Because once we view AI as heavy industry, we realize it crashes into real-world physical limits that go way beyond just wires.
Yeah, the compound constraint.
Right, so the source talks about this AI energy gradient. Basically, AI demand goes up, but power supply stays flat or even goes down in some places, so data centers become hyper-concentrated.
And that creates secondary constraints. It becomes AI multiplied by energy, multiplied by water, multiplied by the state.
Okay, wait, the water piece? Imagine trying to build a megacity from scratch.
Right.
You don't just need the blueprint right. You need the water rights, the political approval, a massive power plant. That's what running the next generation of AI requires.
Yeah, and the water is critical because of thermodynamics.
Right. Cooling the servers.
Exactly. You pump hundreds of megawatts into a building packed with GPUs, it all turns into heat. If you don't get that heat out, the silicon literally melts. And the most efficient way to cool industrial-scale heat is evaporation.
Which consumes massive amounts of water. I read in the source that for every 10 to 50 prompts you ask an AI, it evaporates like a half-liter bottle of fresh water.
Yeah, it's staggering when you scale that up. Millions of gallons just vanishing into thin air.
Wait, really? Millions of gallons? That is insane. So tech companies aren't just looking for electricity, they need immense amounts of fresh water, too.
Right, which brings us to the state constraint. Because power allocation is no longer just a free market transaction, it becomes deeply political.
Yeah, I mean, you can't just siphon off millions of gallons of water and hundreds of megawatts without the local town noticing.
Exactly. You're dropping a new mid-sized city's worth of demand into a municipality. So local governments have to make hard choices. Do we prioritize AI inference, or do we keep the lights on at the hospital?
Wow, so the capital investments get bottlenecked by town hall meetings.
Yeah, permitting, environmental reviews, community pushback. These are hard limits on how fast AI can grow.
Okay, so if these resources, the water, the land, the power, they can't be easily moved, the AI industry itself is basically being forced to physically migrate.
That's the geographic reorganization the source highlights. The AI is physically moving to where the power already exists.
Right, the sources specifically pointed to the Nordics, the Middle East, and certain legacy power grids in the U.S.
Because they need baseload power. Not just solar or wind, which are intermittent, but heavy, 247 power, like nuclear or hydroelectric dams. The data centers require 99.999% uptime.
Think about that for a second. The tech capitals of tomorrow might not be places like Silicon Valley with great weather and venture capitalists, but rather wherever the biggest power plants and the coldest water supplies happen to be.
If we connect this to the bigger picture, we are witnessing a shift where technological supremacy is entirely dependent on legacy energy infrastructure.
So electricity is literally being redefined as a strategic national resource.
Exactly. Energy is a true bottleneck, not computing power. And this creates a brand new inequality structure.
An AI divide.
Right. Regions that possess heavy power versus regions that don't. If you don't have the grid, you're just renting intelligence from whoever has the excess electricity.
That is just wild. I mean, summarize this deep dive for a second. We started out talking about cutting-edge code and algorithms, and very quickly this turned into a conversation about water rights, copper wires, and global geopolitics.
It really highlights how physical the digital world actually is.
Yeah, and to wrap up, the source leaves some really fascinating, open, philosophical questions that I don't think we can neatly conclude today.
Oh, for sure. The branching nature of this whole topic means there are so many unknowns.
Like, Will power be allocated by the free market, or will national governments seize control of it because it's too critical?
Right.
Are we reverting from a digital civilization back to a raw energy civilization?
It definitely feels like a return to brute force physical limits.
It really does. And I want to leave you with a final thought to mull over that builds on this idea of intelligence becoming a resource entirely dependent on electricity.
Okay, let's hear it.
If every single thought an AI has requires a measurable physical amount of energy, imagine a near future where we actually have to ration our thinking power the same way we budget our heating bills in the winter.
Oh, wow.
Yeah, what happens to everyday human innovation when the literal cost of a machine generating a new idea is priced like a rare, depleting fossil fuel?